Hello, astronomy people. Welcome back. So, what I would like you to do is open up that should say I don't know what's wrong with me, Greek Astronomers on Twitter assignment that you were working on yesterday. I do know that you were using the Google Slides to complete that activity, but I want to make sure that you were getting the most accurate information on each of these Greeks. So here's what I'd like you to do is follow along with this presentation and double check what you wrote and make sure you got the right idea. So the famous astronomer tweets, it says right here, someday, Mr. Nicky Copernicus, someday you'll learn that the world doesn't revolve around you. And then the other one is Galileo describes his discoveries to the church. And you can see how that went for him. So we'll talk about all of these little jokes later on. Anyway, the first astronomer that, I don't know what that sound effect was, that you had to look at was Aristarchus. Aristarchus estimated the sizes of the Earth, the Moon, and the Sun, and the distances to the Moon and the Sun. He gave the best estimate that we had for 2,000 years. And what he did is he used the phases of the Moon for relative distance. Now, everything he did was completely inaccurate, but he showed that the sun was farther away than anything we previously thought before. So that's actually a pretty big deal. So be sure in your notes when it says, like, what is he famous for? He measured the sizes of, and I kind of highlighted it in orange, the sizes of the Earth, the Moon, the Sun, and then the distances to the Moon and the Sun. How did he do it? Is he used the phases of the Moon for distance. So I believe that was somebody's image, but just be sure you have these main facts in orange. So he also used eclipses for relative size. Also, those were inaccurate, but he showed that the sun is the biggest object in the solar system. So this led to the whole idea that the sun was the center, and that's called heliocentrism. So again, big discoveries, inaccurate, but he really set the foundation for understanding space. So these are some of the primitive drawings of Aristarchus and his ideas on how we measure distances or calculate size by either using the moon, comparing it to the Earth, or by, making these very primitive sketches that you see. So he set the foundations for more to come. Astronomer number one. Astronomer number two was Eudoxus. And Eudoxus, the big idea here is he promoted the geocentric model of our solar system, which means that the Earth is at the center. So this was the first attempt to model our solar system, a geocentric model. And he was trying to show the motions with this model of the sun and the moon and the 5 planets that are known. All right. Eudoxus said that they all traveled on these transparent spheres revolving around Earth. And he noted that the moon goes the fastest, and then the other planets that are farther out from the moon go slower. And these were based on naked eye observations. At this time, there was no telescope invented. And so here is the problem with Eudoxus and his observations. His idea did not explain why some planets, when you study them in the night sky, move in a reverse direction or do what's called retrograde motion, meaning they appear to go backwards and then forward again if you tracked them day by day. So this is the model. These are the big spheres that the planets were traveling on, according to Eudoxus. Again, at his model, he has the Earth at the center, and then he has the planets that we knew of at the time, along with the sun, going around the Earth and the moon in their own spheres. So this whole model, believe it or not, lasted 1,800 years. 1,800 years. This was the idea for our solar system. Then this guy came along, Ptolemy, Claudius Ptolemy, the letter P is silent. And Claudius Ptolemy still believed in the geocentric model. So he believed that the Earth was the center, but he decided to help out Eudoxus and explain retrograde motion by proposing that each planet had 2 motions. So not only were they going around Earth, but they were moving in small circles that Ptolemy called epicycles. Be sure to write these orange words down in your notes for Claudius Ptolemy, especially the word epicycles. I'm going to show you a diagram for how that works in a moment. So Claudius Ptolemy said, if you watch the animation, that if you were on Earth watching the planets, why do they appear to go backward and then forward? Because they had their own little orbits as they're going around the Earth. And that's why they appear to go forward, backward, and then forward again in the sky. So he said if you track the planet Mars on day 1, day 2, day 3, day 4, day 5, it would be moving forward. But then all of a sudden, if you looked up on day 6, it would go backward, day 7, day 8, and day 9. So he said that they retrograde because they're moving in these little loop-de-loops that he called epicycles. Now, we all know that's not true. But when he explained that, people were like, wow, that's a pretty good idea there, Ptolemy. So the whole model lasted for 1,800 years. But then this guy came along, Nicholas Copernicus. I wrote, he's the best secret keeper ever. He proposed the heliocentric model of the solar system, which went totally against everything you just saw. And that means that the sun is the center. Now, he said that the planets revolve around the sun in the same direction, but at different speeds. And that is why they seem to move backwards. They pass each other. And so, a little history check on Nick Copernicus here. He published all of these ideas in a book called On the Revolutions of Heavenly Spheres. And he received his book on his deathbed. He ended up dying of a brain hemorrhage. So, he avoided all of the controversy that he had published in his book. He died before anybody could get mad at him. The reason his ideas were so controversial is that they went against all of the philosophical and religious beliefs held during the medieval times he was alive. Nobody wanted to hear that the sun was the center. That was the devil's work. It went against what the church said. And so he would have been in big trouble had he lived to see his book. And this is a picture of the Copernican planetary model. Many of you used this in your slides that showed the sun at the center. And you can see that there's Mercury and Venus, then you've got the Earth and the Moon, then Mars, Jupiter, Saturn, and the stars. Because at this time in history, we didn't know of anything that existed out beyond Saturn. That's all we could see in the night sky. So again, the Copernican planetary model was made from naked eye observations. Now, Tycho Brahe, all right, he also worked with Copernicus and he was like, kind of on the fence. He came up with a model known as the safe church model. And what does that mean exactly? He came up with a combined model called the geoheliocentric model. So please write that down for Tycho Brahe. He said, yes, the sun and the moon and the stars circle Earth. So he was kind of going with the Ptolemaic model. But he said the other 5 planets orbit the sun. So he was trying to get away with promoting these ideas without getting in trouble. Now, he did assist another guy we'll talk about in a minute named Johannes Kepler with the laws of planetary motion we'll come up with in just a little bit. So let me show you a model of Tycho Brahe's idea that here it is. Look at this craziness. He said that, well, there's the Earth. So the moon goes around the Earth and these objects orbit the Earth, but then these other objects orbit the sun. Look at how confusing it was. The Tychonic model said the stars are fixed in a rotating sphere, and some things go around the Earth and some things go around the sun. So he called it the geohelio model. We know that's not correct either, but he was trying to save his butt. Then came Johannes Kepler, and Johannes Kepler was a mathematician, and he collected data from Tycho Brahe to support the heliocentric model. So the heliocentric model developed, with this, he developed the 3 laws of planetary motion using that model. Now, why was he allowed to study the heliocentric model? The reason why is he had a position in the imperial court that allowed him to practice his Lutheran faith unhindered. So he was a Lutheran, right? And his religion didn't interfere with what was known at the time. So he developed all of these planetary laws of motion and supported the heliocentric or sun-centered model. So his ideas are revolutionary in physics, especially astrophysics. Kepler's laws, I wrote, we are experts, right? Well, guys, we would be experts on these laws had we been face to face, but I skipped over these labs. But in the labs that we would have done, you would have drawn out and learned how he figured out that the planets are going around the sun in ellipses, not circles. And as they get closer to the sun, the planet moves faster and then goes slower, faster, and then slower. He also showed that they do that in equal areas. Even though the triangles are different sizes, they move around the sun in equal areas at the same amount of time. And then finally, he also showed the law of periods, which means that if you study the distance a planet is from the sun and how long it takes it to go once around the sun, those numbers are equal. So the cube of the semi-major axis, which is the distance from the sun, and the square of the orbital period, which is once around the sun, they made a straight line. Notice that? They go further out when you get to Pluto. This dude right here figured all of this out using mathematics and the model that the sun was the center. So Johannes Kepler is a boss, and we actually still use his mathematical models of the solar system today. Now, Galileo, I put whatever. Galileo came around and he confirmed Copernican theories that the sun was the center of the solar system by using the invention of the telescope. Some people mistakenly think that Galileo invented the telescope. He did not. That was invented by a spectacle maker named Hans Lippershey, and he was an eyeglass maker. So he came up with the first telescope, but Galileo invented his own version of it right here. And he used that telescope to peer into the heavens and prove that the sun was the center of the solar system. He discovered that Jupiter had many moons, so that's why they're called Galilean moons, moons visible with the naked eye. And he was able to show that, yes, Johannes Kepler, you are correct. The planets are going around the sun, but at different speeds. And he saw them closer than any person had ever seen them before to prove that he was correct. Now, big problem for Galileo. History check. At the time that Galileo made these announcements, the Catholic Church was the most powerful and influential church at the time, and they only supported the geocentric model, which was the Earth-centered model. So Galileo was brought forward in Rome in 1633 for heresy. And so under the threat of torture and death, they forced Galileo to his knees to renounce his belief that the sun was the center of the solar system. They sentenced him to imprisonment and life. So Galileo died January 8, 1642. And when he was actually tried and renounced to his knees, he said, "E pur si muove," which means even so, it does move. He's like, take that. All right. However, in 1993, yes, you're reading that correctly. 350 years later, after Galileo died, the Pope formally acquitted Galileo. And they said, and this was in major news, here's the New York Times right here, and there's the highlighted part of the article. It says, and I'll kind of zoom in for you here. "We made a mistake in condemning Galileo Galilei for his arguments that the earth circled the sun. We're sorry, you were right, not guilty." Can you imagine? He was really a passionate guy. And then finally came Isaac Newton. Isaac Newton explained Kepler's laws with his three laws. So Isaac Newton firmly believed that the sun was the center of the solar system, and he came up with the three laws of planetary motion. And so inertia was his first, and he said any body will remain in motion unless it resists a change in speed or direction because an outside force is acting upon it. He came up with the formula force is equal to mass times acceleration, F equals ma. And he also stated to every reaction, there is an equal and opposite reaction. These are very basic laws of physics, astrophysics in particular. And look when he came up with these ideas. He also explained how outside forces on the planetary bodies must be causing them to curve. Hello, sun's gravity. So somebody, I think in their tweet wrote that he was the boss of gravity. That is correct. But be sure on your notes that you explain not only did he devise these laws of gravity, but he also came up with the three laws of how planets are moving. So this is very important because he enhanced Kepler's laws on planetary motion as well. So he showed that the outer planets' orbits are simply larger and curved more gently than the inner planets because they're farther from the sun and they have longer periods of revolution. So the gravity is much weaker the further out you get, all because of Isaac Newton. So Newton's three laws of motion are shown in a little picture here. I think the group in this class even included this diagram in your slides here. So the law of inertia, the law of force and acceleration, and the laws of action and reaction. All right, and it can even be diagrammed out here, showing his three laws of motion. All right, so we're Going to be talking about Einstein next time, but great job on your tweets and your Google Slides. I really enjoyed them. You guys did a wonderful job. All right, that's a wrap.